No beer today. It's serious. There are some, and here in the first two rows, well, come closer together. It's not like in a bus that you should always keep a seat free.
COVID is over.
Per definition. Well, and there, here in these rows there, and you should take off your jacket that you look nice, green or yellow. Other colors are not really cool on the photo. Yeah.
Okay, are we ready to start? Are we ready to start?
So, well, I think we are now really excited to sum up the whole event. We had this time quite a few visitors from coming. Stefan? Yeah. Yeah, well, the first row is always a little bit difficult. Yeah. Well, okay, well, thank you so much for, well, having really a good time with you. I think it was quite intense for everybody of us, you know? In different definitions of intense. You know? Well, and I think to sum up, we had great events, not only here with you, but in parallel with the really young ones. I don't know whether you have seen, we had today and the other days, starting from this size, 6 boys and girls. This was really great, and then intermediate, and today we had a really cool challenge with robotics, cobots, mobile robots and 3D printing, whatever. Yeah, it was really great by Mittelstands Campus. I think was really great. Well, and now I think we have about 25 teams, and in total we were about 600 people on these events. And now I think I hand it over to these guys because they will now kind of torture you, because we have these teams, and per team we have 2 hours, no, 2 minutes and 30 seconds. Yeah, is this right?
We have 3 minutes.
3 minutes. Oh, yeah, we're getting weak. Huh? Last time this was 2 minutes and 30 seconds. Yeah? But, well, then I'm really excited what you will present to us. You excited too? Okay, then Jonas.
Thank you. So I'm really looking forward to what happened today. I've seen some kind of stressed faces this morning or even at lunchtime. So I'm happy to see what happened so far. Looking forward to your presentations. And to speed this up a little, we do this a bit more sportive. So everyone who is in his 30s or younger, try to hop up the stage and instead of taking the long run, Let's see if you can manage to climb the stage when going here for the presentation. Hopefully this will make it more fun for everyone to watch. So, let's see, well, when it comes to flying, how the flying fish guys go. Give them a hand for the flying fish. Oh, that's cheating. So, okay.
Okay, this is a little bit of a surprise. Hello everyone. We are Flying Fish and I don't know how this works. Hallo? I still... It's on, we are on. And I guess our 3 minutes start now. So, no, we don't. So you have to click, please.
Okay, I will do it.
Okay, we start with an imagine. Imagine there was plastic in the ocean. And imagine you have a problem with that and you know how to get it out of the ocean. But you don't know where to look for it because you don't know where the plastic is. And we have a solution for that. Nochmal? The last 4 days we worked on this, or this is only a small part, it's our dashboard. It easily shows you where the plastic is because all of these dots are our buoys standing here in front of you, showing how much plastic is coming by. Please, another click. Our buoys we created with Vishay technologies, and they're amazing sensor technology that are optical sensors. They detect plastic coming by, and so we collect data for that.
Yeah, but how do we actually get the data to our system? Because, I mean, when there's a buoy flying or swimming around in the ocean, it's quite far away. We cannot really see it and get there and see and collect the data. So therefore, we need our drones. And those drones are actually flying across the ocean and in an 8-kilometer radius are detecting the buoys. And therefore, we can get the data from the buoys to our drone and then send it to a base station all around the world. And that's how we can trace the garbage, the plastic in the ocean, and yeah. So there you can actually see it's actually flying. Yeah, it's this drone actually, and we tested it before, and the system with the communication system was self-written, and therefore it was quite nice. So what is actually happening with the data? So our trash monitoring system collects the data and sends it to the dashboard. There everyone can take a look at it and see where the trash is, can see what the lifetime is, or how much battery is there still left in the buoy, and therefore it can still have power, and if there's a malfunction, we can detect it and repair that buoy. And yeah.
Such a challenge can't be faced alone. You need a team for that. And we were a team of 21 persons out of 3 countries from 8 universities, putting a workload of a total of about 550 hours in this project to make it work and look like this. And if you might think we were those who were really pushing it forward, you're false, because those who really put it the hard work and are way too exhausted to stand here and present. So give a big hand to all the team and to Vishay who provided their technology and their time. Thank you.
Okay, thank you so much. So, up next is Team Garbage Collection and Detection. You might have seen them. Up. You might have seen them in the pool with a really cool boat. I'm looking forward to how it turned out.
So welcome back everybody, and hello from our side. we're happy to present the results of our project. So, but what was the reason behind it? What was the problem we are facing? So in the ocean, there's a lot of plastic drifting around, millions of tons. And every year, there's more rubbish coming from the rivers into the ocean, and it's just getting stuck there. So we needed a solution to detect the trash and also collect the trash. But another problem, it's in really remote areas. So how to collect the trash there was quite a big problem, because you can't put too many people resources to those places at once. So to make it really quick, that's the result. We designed an autonomous boat, which is self-controlled, which is detecting the trash via a camera, and it's getting a location, it's driving there, and it's picking up the trash. On the right side, you see our dashboard, so we got a live feed from the camera, and also some data, where's the location of the trash, how far is it away, and also when we collect the data and our bin is full, we get a signal of that.
So what does our product actually do? So the first thing is, it enables us to collect trash which is really far away from populated areas. The other thing is it's completely scalable and modular, so we can pump out a whole fleet of autonomous collecting boats. It reduces the cost of picking up trash by about 63.5%, and it has potential for on-site upcycling. So, in short, what features does it provide? It is completely autonomous. It has high precision navigation, up to 1 centimeter accuracy. It's scalable, and it's absolutely standardized. So the next steps ahead of us, if you guys give us the money to fund our startup, we want to roll out the start of production next year at the 4th quarter, and within 3 months we want to start with the first autonomous fleet. From there on, it should only take a couple of months to have the first megaton of trash collected, and from there on we start developing on-site upcycling and keeping the waters clean and save some turtles. And who wouldn't give those guys billions of dollars to fund our own enterprise? And now I want to give back the word to my beloved colleague, Tony.
And yeah, of course, it wouldn't have been possible without a great team. We were from different universities, from Switzerland, Germany, and India. And especially many thanks to the companies who supported us during that time. Of course, Beckhoff, the company we started the project with, and also MVTech and Fendt, who joined the project on the first day. Many thanks. It wouldn't have been possible without you.
Thank you. So, thank you. The GPT watering team is up. Where are you? Don't you want to jump? Yeah.
I'm sorry.
So hello, we are GPT Watering, and my name is Alexandra, this is Sandro, and now we are going to show you our solution, which is called HydraSense. So our turn was to develop a hydrating system that can significantly reduce amount of wasting water during hydrating, of course, plants.
So we ask ourselves, how can we conquer such a big problem? And we came up with the idea of an intelligent, smart watering system, which has to balance two major parts. Firstly, you have to provide a sufficient amount of water to the plant in order for it to survive in a healthy state. And at the same time, you need to prevent excessive water use, which is our whole point. So on a big scale, that's going to make a huge difference. Meanwhile, you have to keep it simple for the user. So we have a user-friendly interface, and also yeah, you can apply it to a machine or use it autonomously later on. So I'm here thrilled to present our first MVP prototype. It's not only aesthetically pleasing to look at, it's also working, of course, with the Lorentz water meter. And when you hold your RFID chip onto it, it will emit the perfect amount of water for the plant. And here you can also say the user interface, which is kept very simple with all the important details on the side, and a 3D model of the case we can stick into the ground, which holds all components to measure the humidity. Yeah. So, what makes us different from our competition, what makes us unique, is that we've personalized the water use for every single of our plants, while at the same time considering outside factors in real time. So, firstly, we have the personalized infos from our plants, from the RFID tag. Second of all, the weather forecast, which represents the future state, and the humidity sensor, which represents the current state. And with all of that together, we can calculate the best and perfect amount of water that can be used for the plant. And we also added a bit of machine learning coding that learns continuously with time and gets better and better, and learns from past watering.
So how it could change the world? You know, water is crucial for existence living in our planet. So I think it's really nice to care about that. So mainly our solution can improve agriculture markets, especially by improved plants' health and increase yields. Also, it's very good solution for replacing people. You know, it's artificial intelligence. So by this solution, we can mainly reduce time and labor savings.
Okay, so Team OHM, where are the home guys? Give them a hand.
Yes. Hello from We are not the OHM team, we are the OHM team, like the lovely Georg Simon Ohm, everyone know him. And in the last few days, we are a team from 9 persons from Germany, Rosenheim and TH Nürnberg. And we are decided to think about the problem if you have a plant everywhere on the street or in your garden, and what can you do to do the best for the plant. And the problem we decided is we have an unspecific fertilization, waste of resources, and a stationary garden system like here in Gran Canaria.
There should be a video, but we have some technical problems.
Okay, then I will do it manually. No, there is no video.
Okay, so actually there should have been a video, but never mind. Facing this problem, we literally developed a groundbreaking solution in the last few days. Our automatic driving smart farming robot can drive to the specific plant to measure the data, like the humidity of air and soil, as well as the temperature and the brightness. On top of that, we enabled machine vision to detect some pests or other defects directly on the plant. And then you can visualize the collected data in our user-friendly web interface with integrated speech recognition, so you can talk to your plants, as we can say. On the slide, you can also see the machine vision who detects the plants It's not very sharp, but you can see the red rectangles.
I need the presenter. Yeah, thank you. And to summarize everything, we built a robot which is for flexible use, either in home use or in commercial use, which is both possible. The main idea of this is to save resources, so every plant is on its own and every plant gets the right amount of water and stuff that it can grow the best way. And with our user interface we have speech recognition, so it is very intuitive and easy to use, so everybody can use it at home or in the commercial background. And it's also easy to integrate because it's just a web platform, so you can do it everywhere. Yeah, that's the first one. And since this is only a prototype, we want to bring it to a big product and develop it on in the next semesters, and that we have something to do. We want to develop a server and also a web application on the smartphone that is easy to use from everywhere. And what is also a big thing of what we want to do is an onboard watering function, so we can water the plants directly when we are there with our robots. And yeah, that was it. We thank our sponsors, MVTech and Lawrence, for supporting us all the time, and especially Dr. Stetter and ITQ for organizing this great Makeathon. Thank you very much.
Thanks.
Okay. Up next are the engineers. Engineers, let's go. Nice.
Hello everybody, we are the engineers, and today we proudly present to you our solution of the 2023 Makeathon Challenge. As you might know, we were challenged by Lorenz to develop a smart watering truck. Next slide please.
Oh, sorry. Sorry.
Our goal was to develop a system which can easily be fitted to every existing watering truck. As shown on our presentation on Wednesday, our system is based on three main components: the sensor device, the database, and the watering system.
So, our sensor device consists of three sensors: a moisture, temperature, and rain sensor. They are all powered by a solar panel and constantly sending data to the web server. So, for presentation purposes, we added 5 sensor devices. There you can see the locations and the values of the sensors in the table below. So if the plant needs to be watered, the locations and the right amount of water is sent to the watering system automatically. So the next watering system, it contains of a water meter from Lawrence and also a user interface. Via the user interface, you can see the location of the plants, and when you get to the plants, you can start the watering process just by clicking a button.
To get a better feeling how this system can work in real life, we prepared a little video for you.
He's very dry.
Thanks for your attention, and to all our sponsors who were helping us through the whole project. Thank you.
Thank you.
Very nice.
Thank you so much. So, Team Sandstorm up next.
Sandstorm?
Sandstorm. Wir haben bei der Songauswahl mitgedacht.
This is next, right?
Go down.
Down for the next. Yeah. Okay, so unfortunately I need to stop the song. Yeah, I know, but the challenge that we decided to face is the one from the IGUS team that. It was about the collection of the seagrass from the beaches in order to clean it and use it for the insulation purposes as a green solution. And in particular, we took care of the detection and the collection of the seagrass using a rover. And this is the very alpha version of our little rover. And by programming Arduinos and connecting to the motors to the batteries and using the IGUS robot, this is the final result. You can get the audio. So the little camera on front detects the seagrass and stops the motors, so that the arm will have time to store the grass in the box. So as you can see, it can move forward and wait for it. There's my favorite part when it falls the thingy. But yes, so here we go. Safety first, you know. And so, as you can see, it can drive forward until it finds new seagrass, and so that's how the robot works. And actually, the robot can be programmed for different purposes. So it can, of course, pick up the seagrass in order to insulate the walls as a green solution, but it can also be programmed to pick up the litter in order to clean the beaches, but also actually any surface. So you can also use it in a park or anywhere where you want to keep it clean. And our team, it was a small team composed by 6 people. I'm from San Marino, Riccardo from Italy, and Dorimar and Hector from Venezuela, and Mika and Jacob from Germany. I really want to thank them because it was a beautiful experience. It was our first Makeathon here, and we are really glad, and we had a lot of fun here. It was tough but very satisfying. So thank you for your attention. Thank you, everyone.
Thank you. Up next is Battlecat. Battlecat. Okay. So, do you want to jump up with that? Are you sure? Go this way. Okay, let's give them a hand. Battlecat. You want to put it on there?
Yes. Thank you. So, hello everyone, welcome. So today we want to expose our project who's called Battlecat. So to start with this presentation, we are 12 members of 3 different centers, 1 university and 2 super cycle. And here are the team, but we are already 8 that are working there because other people left to where I know.
So 3 of different sites, 2 are programming PLCs, another ones are programming Arduino, others are making all the structure of this project, and then the else are preparing all this project presentation and trying to work out all. So to start with this, the idea has to trying to PLA plastic of bottles need to be recycled as well, because nowadays our plastic is not recycled as it will be. So we try to make this project because this makes more easier to recycle the PLA plastic from the bottles. In a summary, we are using this programming PLCs, programming all the parameters, but it doesn't work already because this doesn't go because the other people that are programming the PLC doesn't come with us. So here we are. And here's the first prototype that it doesn't look like this because it's not working. And so at the first prototype, we are use these different tools and pipes to move the different plastic bottles and then try to recycle. But in the second prototype, it's just like this, and in different pipes, you can recycle the bottles depending on the bulbs, fall, cutting, and fall again, and then go to the shredder and transform in the 3D filament. So here is the programmation of Arduino that makes another companions, and this is working, but already it's not yet prepared because the fluid sim for dynamic motion is not already yet, because we didn't have already prepared the compressor. So we need to check and hit the first hit of the pipe and put it in a pistol, and then try to move this because it doesn't work well. So we try. Here is a bite of the first prototype. We're looking for trying to cut in the bottles, where the valves is using, etc. And so finally, we are agreeing with this project, but it's not finished yet, and we are looking for the next part of the project, try to be more prepared, avant of this. Thank you very much.
Good day.
So up next is Philapet. Where are the guys from Philapet? No jumping?
The clicker?
Brauchst du das? Ah, ja. Je mehr Mikros, desto besser.
Hi everybody, thanks for having me. In the beginning I heard that cat videos are a good introduction or get a lot of attention, so just let's watch cat videos. I'm kidding. It's a serious presentation and a serious topic. It's about environmental pollution, especially plastic or plastic bottles. What do you think? How many plastic bottles are produced every year worldwide? It's 580 billion bottles. And how many countries have a working recycling system? Not so many. So what happens with the plastic bottles? In worst case, they land in the ocean. And until 2050, it's expected that we will have more plastic than fish in the ocean. On the other side, 1.3 billion plastic bottles land on landfills every day. But why does it happen? The material, PET, has a high value. With the bottles that land in the ocean, they have a value every year for 11.4 million euros. And the bottles on landfills, they have a value of 2.5 million euros just per day. That's where we come in. Team Philapet, a partner of BNR. With our smart and green team from US Kempten and others, we developed a progress. We recycle the plastic bottles and produce directly 3D printing filament. Therefore, we throw in the plastic bottles in our shredder. We have the extruder. In the extruder line, there's the cooling, measurement diameter for quality control, a puller, a winder, and there we go. We have 3D printing filament. The specs to our machine, 2 kilograms an hour throughput. Doesn't sound like a lot, but these are 3,200 bottles with just one machine per day. If you get the number, 580 billion bottles per year, there's a market potential for almost 500,000 machines worldwide. Here you can see the shredded material, the extruder with the cooling system, the measurement of the diameter, the puller, and the winder. And here we go. This is the material we produced today with our machine on this Makeathon. It's working. Team Fehler! Team Fehler! Go, go, go!
Great work, guys. So, thank you for this nice presentation. Up next, Taburiente. Where are the guys from Taburiente? Let's give them a hand.
Okay, we are Taburiente. Our group all see the same problem. Imagine for a second that you are an old person and you need to throw the trash and go here, and then you need to throw plastic, then go to the other container and throw organic. We have a solution. We can combine all the containers in just one. We have only container that is divided in 3 zones with a platform that you choose with a button what you need to throw, plastic or organic, and then the platform rotate to that zone and you only need to go, put, throw, and that's all. It's a very simple project, but it's effective and comfortable for all persons that need to throw the trash. That is the final product, and I don't know if you can see it, but it's a prototype now, but it's the platform, the zones, and it's more or less like that.
Thanks. That's it. Thank you to the sponsors.
Thank you, guys from Taburiente. Up next is Exo Solutions. Team Exo Solutions, where are they? Exo Solutions? So, what's happening with Exo Solutions? Okay, still getting ready.
Thank you. Greetings to everyone. I'm glad to represent Exo Solutions here. And we were thinking that, let me breathe. We were thinking that not only complicated devices offer good solutions, there are smart solutions offered by simple devices, just like this exoskeleton. Can you? Okay, this exoskeleton here is a modular one, so you don't really need to buy the whole exoskeleton. I mean, it's really expensive when you have to buy a full suite, when you only need one for one task. And when you are going to screw things, or when you are going to take cables or so, you will have like 15 pounds or 30 pounds in your arm. But this exoskeleton will relay everything in the stronger muscles in your torso, so you can lift them easier. And the other hand is also free to operate and to cable, to plug things or to screw in complicated sites where not every robot are able to get. Next one, please. This is one part we have made. That is the texture of the final design. We have prototyped this one. My mate is carrying here. Next one. This is the photo of the making of the prototype. The next one. And here are our mates working. These guys are from mechatronics engineering. Next one. And this is the 3D design we are aiming to. Well, why? Because we have just 4 days and we are really ambitious, and we don't feel like comfy just by doing something you can for taking cables. We think we should do something even smarter. How? For example, when you are working in cold environments, it could be warming you. So we would like to develop a warming system or a cooling system in case you are in hot places. It also will have a brace, a back brace, right here, for example. The wearing a first aid kit. So in any case you get injured on something, you can aid yourself, or even a coffee cup if you like coffee. And I hope you liked it. This is the final stage of our prototype. She's wearing it. Next. And this is our team. Thanks to everyone who had participated, and thank you for listening.
Up next, Team Cable Kitchen. Please come up the stage.
We're here, now, in the moment, at a new age. Should be louder though. Can you hear it? It is the sound of revolution. We're searching for new innovations, and we are at the forefront of everything. I would like to start the ceremony with this kind quote of Arthur C. Clarke. Magic is just science that we don't understand yet. In this age, we have been working so hard and not smart enough. So, we divided our group into 2 subgroups so we could better manage our workload. We've been working day in and day out for the last couple of days. And I can tell you, it was worth it every single second. So, this is your bag, and you only have one of it. Let that sink in. And you only have one hand. Oh, like 2 of them, I guess. So, together with our partner, Mur Electronics, give it up for them. Come on. We set out on a journey to revolutionize their workplace. And let me tell you something. We expect to corner the market with our products within the decade. So, our first product, the Mur scale. It is astonishing. And the Mur X, it is phenomenal. The Mur scale, if your feet are on it, it sends a signal to the board, and the board lights up if you handle your load not correctly. Because the thing is, with your back, you put strain on it every time you do a bad move within it. So, just a demonstration. Isn't that great? Now you know if you didn't handle your load correctly. And our other product, the Mur X. So, we've been working with cables, those long things. This thing that has other things in it. It's amazing. So, the normal process of it would be to put it in a machine that cuts open the mantle, and you have to pull the other cables within the cables, spread them with your hands and your fingers. It's unpleasant, let me tell you that. So, we set out to make a device. The Mur X. And it is a beauty. It is so beautiful. The design, it's economical. It has some eyes. It's so good. That's it in action. Let me tell you something. The future of tomorrow is now.
Thank you. Well, we're a bit over time, but I think it was worth it. So let's give it up for Team Lift Up.
Team lift up.
So, hello everybody. Thank you for having us on stage. We are Team Lift Up, and we face the challenge of more electronic dealing with social sustainability, so the improvement of the life of a manual worker in a production line. So the problem is the worker has to lift heavy loads every day, repetitively, and with the demographical development, the people grow older and older and have to work longer, so injuries and effects on health increase every year. So what's our solution, Thomas?
Yeah, so we came up with the solution of a robot arm. Yeah.
Doesn't work anymore.
Does it work? Again?
There it is. Yeah, it's a collaborative robot arm, and it allows you to freely move the heavy objects you're about to lift. So if you have a heavy box there, you just guide the robot there, attach it to it, and lift it like it's not weighing anything, and the robot takes the lifting for you. And it also doesn't interrupt the workflow, so even people who are not that good at technical stuff, it's easy to use, so they'll just move it there, and it's very intuitive. Here you can see the prototype in action. So you guide it to, for example, a heavy cable and lift it, and the robot will help you there, and guide it down again. And remove it, yes, and then you can use the robot again. Yeah.
So this was our team. We had Adria, Carlos, Carles, and Miriam, and also Sai, me, and Thomas. And special thanks to our sponsor Muratronic, who supported us and made this project possible. And so to the motivational aspects, why should the worker use it? We are convinced that our system itself is the motivation, because it's simple to use, it's no interruption or no change of the workflow, and it also could be used in various applications with a simple structure, so you can do it with renewable material and you have low costs.
Yeah, and there you can see a 3D model of our future prototype, which we are about to build. It's going to be bigger than our actual model, and yeah, and it also will be attached with a bigger arm, so it can lift bigger things. And we are about to test it with companies together, so we get the feedback and improve and add features which the companies like. Yeah, thank you for your attention.
Okay, up next are Smart Green Garden. Smart Green Garden. So actually, there have been a couple of teams that have been working together to put up this big project. So give it up for the Smart Green Garden teams. Who else wants a mic?
Here. Can I get the clip? Okay. So, hello everybody, nice to be here on stage. We are the team Smart Green Garden. We consist of 6 teams in total, 4 teams working on this project you can see here on different modules, and a 5th team which is working on a project that is nearly connected to it. They are responsible for energy and water. It is not shown here. And then in the background there was a lot of programming to do for the user interface and all that. What you can see here is a really smart farm which is connecting different farms like fish, farming, mushroom farm, and also soil production to do not waste that
much leftovers because yeah, we are living in a world with a lot of wastes, and it is a nice way to use it if other modules could need it. But first of all, let us take a look on where we can get the water and the energy from.
Yeah, so for that I'm excited to present to you what the team AquaTurbs developed throughout the last few days. So we created a 2-in-1 solution. It's a prototype that can generate energy throughout the day with turbines that are attached to 3 nylon sails, and these nylon sails are able to harvest water from moistured air during the night. And so there is all the water flowing through the sails down into a water tank, and that water tank can be generated with the energy that is won during the day. And then there's the pump who can pump up the water too. Where are we gonna go with that, Sydney?
Oh, what's up, Martin? What's our project again?
I think we're the fish farming guys. We try to develop a smart and green fish farm.
Oh, I remember now. So we're the fish guys, and we have a bunch of sensors that actually read data from the fish pond. These sensors are actually sent to a smartphone, which you can monitor and control on your smartphone. You can know everything that's happening in your fish pond. And the wastewater, we send to the farm, and then the soy, we send it to the soy production guys. I don't know what they are going to do with it.
Really? You don't know?
I don't know.
Okay, you're going to know very soon. So we collect the waste materials from the fish farming guys, and we need so many things. So I think the next step is that we call on the farm guys because we need so many help for this soy production. So farm, we need some things for you. What do you want to give us?
So let's see here. So we had water from fish guys and the soil from the soil production guys. And as you all know, farming. We need both of them, and both are crucial. And then we use this water and the soil to do the farming very nicely and properly, efficiently and smart. That's the main part. And we have all sort of sensors that could help us do this efficiently. And then there goes the farming because of the sensors such as water sensors and all the sensors in the soil. We could make this farming more accurate and, like you see, regular. And thus, we do the harvest in 3 to 6 months, and then, you know, our soil nutrients will deplete, and that could result in what? Yeah, we need more nutrients to the soil. So we give the soil to the soil production, Guatemala. But there is something wrong. We have no soil now.
Don't worry, I've got you guys covered.
Okay.
So I get the soil that I've been losing strength and nutrient from the farm, in which after harvest, then we have some loss of nutrient in the soil. So after getting that, I also get the sediment of the waste from the fish pond. So the soil production comes in, whereby we try to mix them together, because all these are, they are organic waste. And in our society, we want it to be sustainable, and we don't want anything to just be left over. And so we try to mix them together in a way that we return the soil back to the farm. And when we return the soil back to the farm, it's going to be the nutrient rich, and every other product and whereby they will be producing is going to be very good for the production of the farm. So the main purpose of it is that we mix the soil and we send it back. And also not forgetting my guys, the mushroom guys, they also need soil. So we give it to them also. We are the good guys.
Yeah, right. So we are doing the mushrooms. Our mission or our problem was to create a farm, a smart farm with mushrooms, so that we can directly automate everything. We are using sensors like all the other farms as well, and are sending them to a program which is then saying when the value of the things are too high. and change them. But I know it's very boring to only see pictures and some people talking, so you are more interested in how it is working out in real. So we have prepared for you a video where you can see all the farms together working, giving stuff to other farms, and yeah, take a look to that.
Ready to go? Okay, I proudly present the SGG groups, a team of 6 different groups from 8 different nations, and we are going to show you the sustainable farming system, smart green climate. So what you see on this prototype board is different modules of a circular farming system. It starts with the energy production, so to say, and water gathering. So we have a dew collection system here. It's going to like fresh water from the mountains, from the clouds, and this water is being then supplied or provided to the first module. Let's say the first module is the fish farm. So what we're going to do here is like we're growing fish for food, and we use the water in a circular way. So what we have here, like on the dashboard, is an overview of the IoT devices that we have implemented in almost all of these modules. So you see here, for example, the water level in the fish tank, some temperature details over there, and of course you can turn on the cooling once the water is getting too hot. So you see here, now the water is the cooling mechanism is made in a way that water is being pumped through the sea to cool down the water without any extra energy, and then it's being circulated back to the tank. And whenever you need fresh water, for example, for the dew collection system, you can turn on the fresh water pump, so you request new water, and then this little pump starts turning, pumping, and then here's the fresh water supply. Of course, we don't need more water because we have an efficient system. Now the water is being filtrated by the filtration system. So we have the filter down here. So the water is being pumped through the filter system and is being renewed, so to say. Now we use the wastewater from the fish tank with the fish poop, which has lots of nutrients, for example, for the farming. So we have the farming over there is the smart farming module. We have an intelligent system of watering. Again, on the dashboard you see different kinds of data like humidity, moisture, methane, and stuff like that, soil temperature. And if you turn on the fresh water supply for that system, you see the water coming through there. And then after a little while, the water is being collected at the end. So it runs through the roots of the plants, and it's being, the plants just get the water that they need, nothing more. Then we use the waste, for example, of the soil, like the plants that haven't grown successfully and so on, to recultivate the soil. So we have the soil production over here. It's a tank which has like a mixer inside and some data, collecting data as well. And the rice starts spinning and it starts mixing the soil, the leftovers from the farming, and also the food or the wastewater from the fish tank, which has lots of nutrition. And then we have another farming module, which is the mushroom station. So the mushrooms over here. Mushrooms have kind of similar nutrition like meat, but of course that's vegan. You can grow food in a very sustainable way. And what we do in this tank, so to say, which is usually under the soil to keep some coolness in the system, is we measure the methane value in here. So this is a methane sensor, and we keep track and keep control of the airflow. So if you look at this fan, for example, on the dashboard, I can turn on the CO2 exhaust, and then it starts spinning. So we keep track of the system in general by IoT and smart sensors and actors. And what we also did in this whole heat is like we used various sensors of different brands. We also use commercial brands, but we made our own systems and own sensors, which most of them are hidden in these gray boxes. But here you see one of these ESP modules, which is sending data to our server, and the server keeps track of the data. And whenever something happens, like a rise of temperature or something like that, the system reacts accordingly, and all this together in a very circular way. So this is the amazing smart green farming project from all our students over here. And I'm just proud to say thank you to all of you for this wonderful presentation of nice projects and prototypes. Thanks a lot.
Thank you.
Ich muss das Video noch. Da kommen wir dann zu, aber 2 Minuten maximal.
So I will just show the video.
Hast du's? So, after this long video, it was quite hard to understand. We have another video for you, but I'm going to talk over it. We don't have sound for this. So, in close contact to ITQ itself, we developed a platform, a user interface for all of this stuff. And it's more than the project you just saw. Some of you provided me with sensor data through a connection called MQTT, and we put everything together to control it and monitor the sensors and stuff. And there's the reason behind this, because we were farming for over thousands of years, and we are smart guys here. Of course, we can do stuff like this, but there are people outside that want to farm as well, and we need to give them an easy opportunity to do it in a smart way, like we did here. And that's this platform. Like you can see, we have integrated the farm bots all over the world, in Gran Canaria, in Germany, and we have integrated our SGG projects. You will hear from Sun Pirates, I think, after us, and from Bogota. They didn't make it in time to provide the sensor data, but they could be in here as well, and that's the whole point, to connect everything together. Yeah, thank you.
Okay, so we are now up next with our guys from Bogota. Until we set this up, I would say everyone stand up. Let's do some movement together. Everyone get up. Okay. Stefan, can we get some music?
Of course we can. So
all right, so all the hands up, no photos, just gymnastics. All the hands. And going down.
Bogota, are you ready?
Okay, I think Bogota is ready. They are also on live stream, so they might think we turned crazy in the meantime. But thanks for joining this workout.
So, here's Team Bogota. Maybe you can switch on the camera. Team Bogota, can you turn on the camera and show what you have done?
Hi, Bogota.
Hi, everyone. Hey. All right.
Hi there.
Listo? Estamos. Can you hear us?
Yes, we can hear you.
All right. All right. Should we start now?
We are ready when you are.
Okay, great. Hi, everyone. We're able to. First of all, we wanted to thank the ITQ and the Universidad de los Andes for this great opportunity in participating in this amazing event. Second of all, we wanted to talk about Raul. Raul is a retired engineer. He wants to finish his life by farming some vegetables for himself and his family and make this in a most automated way possible. He wants to take the data from his crops and analyze the best fertilizers, time to water, and best conditions for having some good crops. He bought a farm bot with some money he had left, but taking the data he wants is not as good as it should. We wanted to help Raul by developing a system with wireless sensors that measure the critical environmental conditions that he needs, such as temperature, humidity, soil moisture, and nutrition. With this information, Raul will be able to decide which fertilizers used, how much water his plants need, and in general, monitorize his plants in a modern, fashion way, making his life easier.
All right, so this solution is not only going to be helpful for Raul, but also for every single person or agronomist that has interest in automating the recollection of data of their crops. Data such as nutrition, nitrogen, potassium, phosphorus, humidity, temperature, electroconductivity. Well, I mean, all this kind of data that could dictate good methods to take care of the crops. So, our prototype features a CAD model of support from the MPK structure, the real montage of the MPK, some humidity and temperature sensors that we developed here, and the real montage of those sensors with a waterproof case. And some of the next steps that could have this project could be collect data from crop images with artificial intelligence, include more sensors in our IoT architecture, or, well, some other kind. We also develop a dashboard. We design a very intuitive dashboard in which the user can see in real time the behavior of the variables of interest. The sensor nodes connect via MQTT to the server and send the actual soil moisture, relative humidity, room temperature, and MPK nutrient values of the crop. Thank you.
These are the prototypes. As you can see, this is an MPK sensor. And that other one is the one that measures the humidity and temperature, both of the soil and the environment.
And here's the same sensor with the waterproof case that we designed here. And that's it.
Thank you so much, Bogota. All right.
Oh, thanks, Bogota. Now they can hear us. What? Now they can hear us, so clap again.
Now they can hear us. Now they can hear us.
Yes, we hear you. Thank you. Thank you very much.
Thank you, Bogota. Bye-bye. I think you can see the rest of the stream by our YouTube stream. Bye-bye.
Oh, all right. We're missing one presentation still.
Ah, so there's one coming. Okay, then of course.
Okay, there's one to come. Are you ready?
You can just begin.
Hi, can you hear us?
Yes.
Hello? Okay,
Yes.
nice. Okay, we're Siegua.
We are the second group, and also we want to thank everyone that helped us to make this possible, like ITQ and the University of Los Andes. And we are going to start by presenting our problem and then continue with that.
Okay, so our main problem, or like the general problem, because we worked on an aquaponics system, is food production capacity currently could improve. Yeah, okay, so the problem is we can improve food production capacity because in the future, if population
like the population, if the population grows like a lot, like is going to happen, we are going to need a function agrolab or aquaponic, that is our subject, that is going to help you to give food to every people in a sustainable way. So basically, in our aquaponics, it's like a first version. Like, it's very simple, has their plants, their fish, but there are a lot of work that we can do. So as you can see, we have some solar panels, but they were not working. And it's very simple, but it's very cool also. Daniel. So for our solution, the aquaponics have many problems, but we are going to, or we focus in 3 main problems that we found. That was that we needed like an automated data measurement system that is going to help for the management of time and maintenance of the aquaponics. Also, as you see in the previous video, we are going to, we connected the solar energy system and make it more sustainable. And finally, we create a database and interface that is going to visualize all the measurements that we take of the automated data system. So for the automated data measurement system, we make the connections, we make the programming in Arduino, we make the calibration of a pH sensor and a temperature sensor. We create some supports that is going to maintain the sensors in constant connection with the water, and is going to take all the data. So as you can see on here, you can see the support that we make written on 3D. And here is like the magic box, like has all the content that is going to make all the magic happens.
Yeah, we had a problem like about half an hour before the event started. Here, if you want to go to the next page. Okay, so the part about creating a database and an interface, we had everything set up. We set up the database, but half an hour, our system depended on a Raspberry Pi, and the SD card got corrupted, like about half an hour before the event. So
it was a shame, but
yeah, it's a shame, but we had everything working, and yeah. So basically, the system is we have a Raspberry Pi that basically connects to the database. So what the Raspberry Pi does is it gathers all the sensor information from the Arduino. It uploads it to Cloud Firestore, which was our backend, and it also sends it to the MQTT servers that you guys had. But yeah, it stopped working.
So let's see. So in the impact of our solution in the market, or what we try to do is to make the aquaponics of future developers more sustainable, like with all the measurements. They will be more supervision, it will be more easy to maintain the aquaponics, and it's going to help to the time management. And finally, we also want to give the manager an historic of data that is going to help them to identify all the problems that they made and correct them with more facility.
Thank you so much, Bogota.
Thank you, Bogota.
Thank you.
Thank you, everyone.
Thank you. So, up next, the Sun Pirates.
So, Bogota, we will close down the stream and you will follow us with the YouTube, right?
Yes.
Okay, bye-bye.
Bye-bye. Okay, give it up for the Sun Pirates.
Ich präsentiere, ich bin alleine. Hi.
Hast du so ein Ding? Yes. Haben wir den Zauberstab?
So, we are the Sun Pirates from FH Technikum Wien from Vienna. And I would like to present you what we did. So what was our mission, firstly? We wanted to create an international team. As you can see, Nisreen is here from the University of Las Palmas. Another goal was to produce sustainable energy, but more efficient and smart, and also use cloud intelligence for as an interface for multiple trackers. As you can see, one of the most important goals was also to be happy. We had a lot of fun. I know I look a little bit mad, but I had problems with some sensors. But it doesn't work.
Try once more.
No. So, our solution was to build a solar tracker. Why a solar tracker? Because with a solar tracker, we are about 30% more efficient than a normal static solar panel. We also used IoT. Why IoT? Firstly, because we wanted to implement the tracking algorithm as a service. Secondly, we also did it for augmented reality with live data. And one of the most important reasons is to connect to other projects, such as Smart Green Garden. So we thought, let's work together. So now you may ask, what did we accomplish? We assembled 2 trackers, one small cute tracker, and another one that was both are tracking or following the sun. We collect live data from both solar trackers with MQTT. We produce to 35 watt power when we face to the sun. And one of the most important things that we accomplished was to learn from each other, not only technically, but also humanly. So I would like to show you our results. So in the future, we would like to do the same thing, but with a PLC from B and R. So also thank you for your collaboration, because you helped us a lot. We really enjoyed it, and I would like to thank everybody that made that possible in the name of our team. Thank you very much.
Thank you so much. We stick to solar, and up next, Team Solar Scooter. Give it up for Team Solar Scooter.
Hello, we're from Team Solar Scooter, and do you have the presentation? Thanks a lot. Yeah, so we're Team Solar Scooter. That's Sergey, Ada, who's eventually not here because she had to took her flight back to Germany. And there's me, Lucas, Axel, Sammy, and Adrian. Yeah, so we're from Optima, and yeah, we had a little chat. It's not working. Ah, so perfect. Yeah, we had a little chat and thought about how good are e-scooters. And we like them. They're really good, they're eco-friendly, but then we thought, are they really so eco-friendly? And you think maybe they are because they use energy and not fuels. But actually they're not so, because if you know the rental system from e-scooters, they in the evening collect the e-scooters and drive them to a charging port where they're charged, and then they drive them back. And that is actually a big problem sometimes because, yeah, you lose fluid energies. So we think about why don't we just put a solar panel on the scooter to charge it during the day? And we did it. So we at first had to assemble the electric part, which is the black box down here. And we did the mechanical part to have a better angle for the sun. And it works, so great. And then we built the prototype and everything worked out very good. Here's a video of a proof that the scooter actually works. If I click, maybe. Oh, sorry. No, it's not.
Let me help you.
Okay, thanks. So, yeah, you can see there that we have 0.4 amps of current, and the solar panel is around at 16 volts, and the battery system is around 36.2 volts, so everything is charging and working. So as a conclusion, we successfully assembled the prototype, and we charged the battery with solar energy, and did a folding mechanism, this one, to get a better angle for the sun. And our next steps would be to get even a better working system more efficiently, so we can maybe chat with the sun pirates for their tracking algorithm, so we can track the sun a bit better. And we want and we want to increase the safety, because if you look at the scooter, it can tip over easily. So maybe we should put it in the board, something like that, better place. We have to figure it out. So, but thanks a lot.
Thank you. Let's go to the wheat teams. So the seaweed sorters. Where are the seaweed sorters? Come on stage, please.
Seaweed sorters. Don't forget the other seaweed team.
Yeah, there's plenty of wheat.
Okay. We seaweed. Seaweed sorters?
Yes. My bad. That's okay.
Oh, hi Simon. It was a great week on the Makeathon, wasn't it? So, what's your plans for the next week?
Hey Christian, it was amazing. I think we cannot compare to this. Yeah, I would like to build a house when I get home.
Isn't that totally exhausting?
Well, there's one big challenge, yes.
One big challenge?
The seaweed for the insulation.
The seaweed for the insulation? Are you sure you want to build a house?
Absolutely sure. Using natural material that would be otherwise be highly expensive to dispose of works perfectly.
That sounds like a win-win situation. So, what is your problem?
The seaweed is full of garbage and trash and sand.
Well, you're lucky that the seaweed sorters have solved the problem for you. Let me show you.
Our solution is the seaweed sorterer. It's a smart green machine to separate garbage from seaweed. Let me explain you how it works. You see here, two different camera angles of the same process. In the first step, we have a lattice structure which is vibrating and so separates smaller pieces of garbage from the seaweed. And in the second step, we detect the bigger parts of the garbage which remained on the plate by using a camera system which is mounted on the robot arm. And using an AI, the cobot knows where the bigger parts are on the plate and can then grab them. We use the IGOS Rebel cobot to do so, and it puts them on the belt. Yeah, normally it should land in this box there, okay, it's a prototype. And the last step is to tilt the cleaned up seaweed into a box.
Now I will going to tell you how our solution impacts the market. First of all, the expensive disposal of seaweed is eliminated mostly because the clean seaweed can be used properly now. For example, at a beach of approximately 100 kilometers, there are around 50,000 tons of seaweed every year all around the Earth's coasts. So a lot of material to be used. House building becomes cheaper, greener and more sustainable by using local materials that are right around the corner. Also, the seaweed can be used for medical products and produce blankets and fabrics.
And here you can see our great team, which has done a great job the last days. Our team consists out of 12 people from 3 different countries and 7 universities and companies.
The next steps to improve our prototype and its possibilities are to scale it up to industrial dimensions and to connect it to maybe prototypes of other teams and groups, which we'll see soon in the next presentations. Finally, we would like to thank everyone who made it possible for us to develop this prototype, especially the IGOS team, ITQ, and of course, Dr. Rainer Stetter. Thank you.
Thank you, guys. And up next, We See Weed guys and girls. We See Weed. Let's give them a hand.
Yeah, that wasn't quite a big hand. Let's try it again. A great product needs a great introduction. So, ladies and gentlemen, it's time to meet the makers from KPO and FHNW, powered by Sigmatech, the best seaweed dryer in the world!
Hello, yeah, this is our prototype for drying seaweed, and there are 2 motors where you can switch from external to internal air, and it's all controlled by a PLC, you can see in this picture. And a lot thanks to our sponsor Sigmatech to make it possible to do this really cool project. Our prototype is using sensors, the weather forecast in an intelligent way. So when it's raining outside and in a few days it's better weather, the machine is stopping and awaits to the sun for drying, so you don't need much energy. And we're also using humidity sensors where I collect all data, and so we know how much we have to dry. And all in all, it leads to an energy-efficient way of drying seaweed.
Yes, so now you saw how our prototype works. It's possible to use it for seaweed. The advantages of drying seaweed were already explained by the previous group, but furthermore there are many other possible applications in smart farming, such as drying hay or drying corn and many more.
Thank you. We See Weed. Okay, I think we have one more team missing. Let me check before I say anything wrong. Well, missing 2. I guess the Doug Norris is missing. So, pardon? How could that happen? I'm so sorry. So, let's go with Watering Smart. Give them a big hand. Okay, you have all your prototypes with you. Let me make some space. Want to put it on there? Put this down? Okay, I think it's too heavy, yeah. Wollt ihr das aber vortragen? Transform? Wollt ihr das ganz vortragen?
Wie funktioniert das?
Okay, we will have a live demonstration on stage, it seems.
That's the plan.
Nice. But
get the fire extinguisher ready.
Thank you. Sorry, there are 3 minutes more till you get your beer, but I think we can start.
Yeah. So, thank you for having us. Thank you for just almost forgetting us. And yeah, we are Watering Smart. Now, you're probably asking, why Watering Smart? What does it mean to water smart? Well, to talk about that, first let's talk about what it means to water dumb.
Hey, what the hell are you doing there? Yeah, I can see this, but isn't that inefficient?
Yes, it is. It's quite inefficient. But we at Watering Smart have the ideal solution for you. So, what do we want to do? We want to build a grid throughout the entire city, through all the greenery, to build a smart solution to water that greenery without any human intervention. And with that, we can save a lot of water, a lot of persons, and a lot of water costs.
Okay, but that sounds great. Can you show it to me?
Well, obviously I can. Please, come here.
Okay, what do I have to do?
Well, first you'll have to take the humidity sensor and put it into dry soil, please.
Okay.
So, now as you can see, there's water coming out of here. Usually it would be watering the plant, but with that system, since it's for like large scale, we would probably drown the plant. So, please place the sensor back into the wet soil. Thanks a lot. Thank you. So, as I said, we want to build a citywide scalable network, and we also want to use the weather forecast to make it even more efficient. To optimize that, we have local weather stations within our module. So every module doesn't just know how wet the soil is, it also knows, is it raining right now? Or how bright is the sun? Because you don't want to water your plants when it's too bright, because they'll burn. So we have that included too.
That's very interesting, but as a local, can I see those data too?
Well, obviously you can see those data with our smart web interface. So every station is obviously IoT connected, and I won't bore you with like all the technical details, because let's be honest, nobody who buys those things really cares. But you will have a fancy screen that shows you everything that your station can see and also what it's doing.
That's great, but it wouldn't be possible without our team. So a big applause for our team. Thank you. And now the last group, I think.
I think so. Well then, let's go, Doug Norris.
Thank you so much, guys. So just to be sure, is there any other team I forgot? It's been 4 really intense days for me as well, so I might get a bit crazy. So I think Doug Norris is the last team for today, and I'm really looking forward to your presentation.
Thank you. Let's go.
Hey guys, it's Doug Norris here. So you may wonder why Doug Norris. So the whole idea started with slugs actually. So slugs eat a lot of like vegetables and stuff and ruin gardening. So we thought, what's the natural predator of a slug? Well, it's a duck. So we thought maybe we can create a mechanical duck. So yeah, sounds interesting, but we thought we could do way more than that. So we thought maybe we create a smart digital gardening robot. Well, and then we arrived at the Makeathon. And what happened next?
Well, our idea was depending on the equipment of the sponsors. Gladly, we found IGUS and MV Tech, 2 great partners to work with. And well, IGUS gives us or offered us his robot and the gripper, and MVTech on the other side provided the machine learning software, and the camera for the vision object detection. Yeah.
Okay, so let's go on. We did here a lot of making, as you can see in the video. It's really a lot. First, we had to plan our stuff. Well, then we had to deal with the object detection. It was quite complicated. We also had to do a lot of hardware stuff, and well, we also had to do some wiring. We had to wire some pumps, some sensoric, and obviously the robot arm. And well, that was the making part of here. So I think, and next we present you our Doug Norris. Thank you.
Thank you, ITQ, thank you, MV Tech, and thank you, IGUS, for sponsoring us.
Thank you very much.
Thank you, Doug Norris. And thanks to all of you for all your awesome presentations. I think we give a big hand to all of the teams. I think you did an awesome job, all of you. Thank you. And now, Anis, please come on stage. Oder, yeah. Anis? Yes. A pointer? Yes. To change it. I don't know if it's possible. Yeah, but I don't know. Can you see it? No. No, if it's not working, it's not. Okay.
Just here, no? So, hello everybody also from my side. I think the last and also important point is social media. So we have just a little recap what we did and achieved so far, what you did, and of course we have the winners to announce of our social media challenge, and then I have also for you all a little, surprise. So just have a see. I think it's not working.
The lower button.
Yeah, I pressed, but it's no problem. You can press also. Next slide, please. Yeah. Here just some impressions about the participants, or also what the sponsors and partners did. Next slide, please. Here as well. Yeah, stop. Yeah, so far I'm just a little bit happy because not all of you did or had the chance and the time to do something. And if he did something, it was not related to the Makeathon content which we announced before, but it's okay. I hope and wish that you the next time will do much more, because as we mentioned, it's important and nice to share and spread to the world what we did. So it's up on to you to take this chance. And I think all of you had a lot of fun, right? Woo! And thank you. And I think exactly that what you felt these last days. You had the chance to share it and spread it with the word. But it's okay. We have 3 winners, and I will present them right now. The first winner will just get 300 euro. We increased our total amount for the first prize. Before it was about 250 euro, and now he will get 300 euro. Why? Because we got the support of a sponsor who just increased our amount. Many thanks to our sponsor who did that. Just big applause. Many thanks to him. I think it's a great opportunity and chance, because 300 euro is a good budget to come and take place, or to take part at the next Makeathon next year, and to join us on Gran Canaria again. And I think you had a lot of fun and also nice moments besides to the making. So, the first winner is, it's a little bit difficult name, but I will try it. It's Kushimeta with 232 likes. Big applause! Please come on the stage. Yeah. So, thank you for sharing, and congratulations from our side. My colleague will give you the prize, and the voucher you will get digital. We will send you our prize digital. Okay? Let's say that. Big applause. So, that is one opportunity to get a lot of likes, but there are also some other pictures and ideas. Let's switch to the second place. The second place is a total amount of 150 euro, and the second place goes to, also another time, it's a very difficult name, but it's okay. It's Sydney. Sydney, where is Sydney? Come in, come in. Nice. Way, big applause. That is a boy. Wow, great. Great. 46 likes. Yeah. Here you will get, just the other side. Congratulations as well. And you will get a voucher digital. Yeah? Yeah. Thank you. You're welcome. Nice. So, the last winner of today We will see. The third prize is a total amount of 100 euro, and the third place goes to, okay, this time it's okay. It's not so complicated. Albal Meidi! Big applause! 41 likes. 41 likes. Come on to the stage. Nice. You're welcome. And yeah, you will get also the digital voucher from us. Okay? You're welcome. So, now I think we come to the end, but I promised you that, or I told you before that I have a little surprise for you all. So, do you know what it is maybe? Yeah, for us, yes. For us, it's Carnival. And tonight, we will do Carnival. So, next slide, please. First of all, thank you all for taking part and having just so much fun. And, yeah, to join us here. And therefore, I prepared for you a surprise. Next slide, please. We just finished, just in time, the short impression after movie of these 4 days. I think that's great. Big applause to the whole team, social media team. Really, thank you very much for this great job. And I let you all decide about it. And I would like to say, let's go, play up. That was our Makeathon in the short movie. At this point, I would like to thank all participants, all partners, sponsors, and of course, our team. And I will give up. Thank you very much.
Well, now we're done. I think you're a little bit tired because of different reasons. Yeah? I saw as well the WhatsApp group. The last post, I think, was last night, 3:40. Yeah? And therefore, I'm really impressed that you're all here and only a few sleeping. Well, and now here are the universities. We saw already the sponsors here in the first 2 rows. Please give them a big hand. Stand up, the first 2 rows. Well, and then I think we have to thank as well our team. Please, our team. Come on. Come on, more. No, move, please. Well, we are all a little bit tired. And this is really amazing.
So, everybody thanks everybody, and Rainer thanks his complete team. But the sponsors think, or we think, the old father of this idea, of this Makeathon, of this great event, should be a special applause. Rainer, thank you. Yeah, give him a big hand, a big hand! Without his inspiring ideas, without his energy for this idea, we are not able to participate here. So have a great thank again, Rainer. Have a great thank to the whole team. You did a really great job. Thank you very much.
Thank you. Well, it was really a pleasure to have you all here, and it was really a little bit exhausting because actually, well, we did already, well, before COVID and even during the time of COVID, this Makeathon, yeah. Well, and we had to reanimate this dead patient in a very few months, because normally everybody's talking already about the next event, and he told me we have to start more or less next week, and I will have the next meetings the next few weeks, to push a little bit here the locals. Some of them like me, others no, well, it's great. It's a great picture here, and it's really gives me energy. I lost some energy the last 4 days. I almost didn't sleep for several reasons. And without you, this would be nothing. And I'm really happy that you come, and you make, and not to glue yourself somewhere. This is very important for me. And as some of you were at the adult, the VIP event yesterday, and there was a lot of energy, and everybody was talking what to do next. And we have a lot of energy. We have still a lot of ideas what to do. My dream is to fill up this Palacio de Congresos, every place, every seat. We want to do. We want to add a congress to this event, and as well we want to go around the world. There is our dear friend from Botswana. Raj might be as well somewhere. India, in the last row. Our friends in Bogota, we have here. We were with this event on 4 different continents. And we want to go around, and we want to travel around the world, and we want to stimulate the youth. We want to do new things. We want to really change the world. And I need you. Well, and we have to talk seriously about some issues. I want really to push up the whole energy which we have here locally. Therefore, a big hand for Sergio Alonso Foundation. There is Naira, there is Evelyn. Stand up, please, and give them a big hand. Without them, we couldn't do this, what we have done with the even youngers, which are not here now because they left already, and this is really stimulating, and this is really gives me energy, and there's one thing, I thought we are only 25 supporting this event. I don't want to count how many people are now on the stage, and it's good that I'm a technician, not a businessman. Otherwise, I wouldn't do this. Yeah. And therefore, we have to talk a little bit with the sponsors how to split up a little bit the pain, because this is painful from a business perspective. Yeah. Well, but to sum up, I think we are almost done, but there are some nice guys waiting.
Rainer, and to all of you, a big thank also from the universities. We're so glad that we can bring our students to that place. And there are a lot of people around in the background doing things we don't see, but making us happy and making a seamless event. So we don't have the noise, and we have food, and we have the litter deployed and everything. Thanks a lot for organizing that great event and for all the work you do in the background. Big hand. You have to.
Thank you so much. Well, and now we are really done in several interpretations of life. Well, now there is still a little food there. It was sponsored by the Spec, therefore it's not that much. Sorry for this joke. But we have still a lot of beer. And as well, what is very important, we have these documents, these certificates for you, which you need for your CV and so on. And then we are really done, and give us all a big hand. Okay. Bye.